All right, so again, we're going to reason about where this is our new g prime, flipped left to right from the previous one. We're going to reason about where the original g, the new original g, is increasing or decreasing. So again, from here to about there, g prime is positive, g is increasing. From here, sorry, that g prime is positive all the way to here, isn't it? Not there. And then here to about there, g prime is negative, g is decreasing. And then from here pretty much onward, g prime is positive, g is increasing. Okay, and then how about where the original g is concave up or concave down? The g prime is increasing up to here. That's what I was looking at when I should have been looking at just plain positive. G prime increasing, g concave up. And then from here to about the middle there, concave down. From here all the way over to here, concave up. And then from here on out, g is concave down. G prime increasing like that, g prime decreasing, so g is concave down. So one technique some people like, other people don't, is to draw vertical lines wherever something interesting happens here, wherever either increasing, decreasing changes or concave up, concave down changes. So we could draw a vertical line here. I'm doing it in pencil just so the thick ink doesn't get in the way of seeing the graph later. And then drawing a vertical line here, drawing a vertical line here, vertical line here, and a vertical line here. And that segments the graph into regions of different behavior. We can even summarize this up top. So we need g to be increasing concave up. Here we need g to be increasing concave down. Here we need g decreasing concave down. Here we need decreasing concave up. Here we need g increasing concave up, and then g increasing concave down. Another way to see this, what points did I just hit here? I hit a local max, I hit an inflection point, I hit a local min, I hit, what is that? Gotta think about that, huh? I hit a local max here. Is that kind of an inflection point of g prime? That's not an inflection point of g prime. I think I mixed up my logic over here. This is an inflection point, but really what it is a zero crossing. That's where g prime crosses the x-axis. So I've got where the derivative of g prime, g double prime, is 0, where g prime is 0, where g prime has a flat tangent spot, so g double prime is 0, where g prime is 0, where g double prime is 0, and that's all the rest. So another way to think of it is draw vertical lines where g prime crosses the x-axis, where it has a 0 here and here, or where g prime has a local min or max, or saddle point maybe, and that's another way of saying where the lines are. Okay, so now let's do the same sketching. It still says starting at g at times 0 equals negative 0.5, so we're starting here. And we're pretty flat for a while. And then we need to be increasing concave up. So it's kind of hard to know how increasing concave up to be, like should it really rise up like that? In some sense it doesn't matter. It would be on a different axis, different y-axis anyway, because it would be on the kilogallons rather than kilogallons per minute kind of scale. So just some concave up increasing function is fine. And then we need to be concave down increasing. So we could go, it doesn't have to hit that spot. We could come a little short of that maybe. And then we have to be decreasing concave down until we get to there. And then we want to be still decreasing but concave up, so kind of flattening out a little bit. And then we want to be increasing concave up until we get to 6 here. And then we want to be increasing concave down like that. So this is our original G. And then taking a step back, did we get the same curve as up here, but flipped left to right? Well, this little bobble is now over here, so that did get flipped left to right. But this little wiggle bobble, it went down and then back up initially. Here it goes up and then down initially. So it's actually flipped left, right, and up, down, which is really interesting, and maybe we'll see an explanation for that later in the class. Let's switch and show the actual curves that I've got in Excel here. All right, so here's the actual curve again. G prime is the red curve, and the original function G is the blue curve. And I think my what I drew was too tall. It came up here and then back down, but it did have this little wiggle. And then if we check the left-right flipped data, I think that looks a fair bit like what we just drew.